Building geodatabases. What is a geodatabase? A spatial database or a geodatabase is a database that is optimized to store and query data that represents objects to find in a geometric space. Most spatial databases allow representing simple geometric objects such as points, lines, and polygons. A geodatabase can store, edit, create, and manage GIS data. This is where all your data is going to be held and accessed. It is able to have featured data sets, featured classes, which have your tables and relationships, and also have topology and geometric networks. You can also include rasters in this. Your geodatabase is pretty much going to have all your data and put all your data to use. This is going to be your main storage, your main software, and you're going to get your main usage out of this database. So let's talk about building a geodatabase. Building geodatabases, we'd like to begin with a model. A logical model, a conceptual model, and a physical data model. And all of these can come together to be the implementation of your geodatabase design. Your logical model would be the way you'd like to set it up. Maybe you've got some thoughts in your head on how you'd really like for this work to flow. Your conceptual model may be you've written down some things on how you think it's going to flow, where you think things are going to go. And your physical data model is going to be actually putting these ideas and conceptual and logical models together to form something physical, such as actually putting it into a computer or setting up your database. And this is where the implementation of your geodatabase design comes in. Your database is going to be implemented in 3 phases. You're going to start with a prototype, something kind of basic. This is what I think I'd like to have. This is what I think would like to go into it. This is, this is kind of my goal here. Then you're going to make a pilot database from your prototype. Okay, these are the things, this is the goal I'd like with a prototype. And, this is how we're going to get it off the ground with what I've got for the prototype. And then with this, you can make a production database. So you'll take the lessons learned from your prototype and things that work from your pilot database, and those things will represent your production database. And after that, you will build, test, and revise, and probably test again and revise and maybe build on and keep doing these steps until you've finally got a database that you think you'd like to implement. So there are 6 implementation steps. The first one is to obtain or develop a design. Then you'll modify the design, load data to the design, build topological relationships, test the model, and revise the model from what you've tested. So the first step, obtain or develop a design. So here are some design options. You could use a template, import an existing, create a new one, or use a UML model. So you'll obtain a design. So first, obtain a template. You can use an existing database and customize it to your current needs. Or you can import data into your database and modify existing feature classes or tables into what you're using now. So if you've got a project that's pretty close to something that you've done before, it may be pretty easy just to take your old information and supplement it into either a template or another geodatabase. But let's just say you've got something that's radically different or you'd like to do something completely different. You could create a brand new database and add data into an empty database so that you could have something from the ground up that is exactly what you need, using the data that's different or a design that's different. Or you could use modeling tools such as Visio or Rational Rows to develop your design. At this point, it is really important that you have a spatial reference set up. That way that all of your data is going to be on the same page and you're able to layer it accurately, and that the position of it is going to be easy for the user to understand. And you know, it really does help because this is a geo database, meaning that its units are congruent to the Earth. So to have it positioned correctly is essential. No need to start off early in the design and have your data in different places. Implementation step 2, modify the design. So with the template, you'll have more editing. Do I need this data? Do I not need this data? What all data do I have exactly in this? As opposed to a new database where you start from scratch and you decide what data goes into it, and it's pretty clear on what data is in something new than something maybe used 3 months ago or a year ago. Also, you could use a case or computer-aided software engineering. So basically, for the modify the design, we're going to add, remove, rename the data. We'll be adding and removing feature classes, modifying feature classes, adding and removing table fields, changing relationship classes, changing domains, associating domains with attributes, and associating editing behavior. We'll be, with a template, you know, your feature classes may need to be added or deleted. At this point, the subtypes can be added, deleted, modified, change the feature class name, move existing data. The tables may need to be created. You might be changing relationships or getting rid of relationships or creating relationships, maybe adding or deleting domains, adding tables, feature classes, subtypes, or merging or splitting policies with tables, feature classes, and subtypes. So, while you're modifying your design, a lot of these things are going to apply. Loading data. When you load data, you're going to need a couple considerations. What type of data are you loading? Is it going to be compatible with my database? Typically, you can use text and shapefiles and rasters. Is it going to be too big? Is it small enough to where I can load it and it won't take too long? It's not going to, lock up my computer or anything like that. And the contents. Is it another database? Are they tables? Are they points or lines? Or, what type of what does this data have in it? So how are you going to add this data in? You can import it, you can load it, you can derive it, you can digitize it. There are different types of data you can load: features, annotation, dimensions, rasters. I think that's the beauty of the geodatabase, is that it takes all sorts of different data and allows you to load it in and create different relationships with it. For example, you're not only limited to survey things or weather patterns. I mean, you can use it pretty much for anything. Here's an example of using crime data and importing it and using it for all sorts of things. Build topological relationships. There are two types: geometric and a topology. For the geometric networks, there is a lot of building to get a good flow with these networks. And I think the main idea is to have flow. You want to select a feature class and name it and identify complex edge features. Then you want to give it some snapping or snapping tolerances. Identify the source and sinks. Add weights if necessary. Then apply your connectivity rules and create default junction types where needed. Building topological relationships. It's very similar, but yet it's a different idea. You'll want to name it, then give it a cluster tolerance. Select the feature classes that you'd like to apply. Give them ranks. Make rules and validate those to make sure that your database complies with these topological relationships. Test the model. So you're going to want to test everything that you've gotten so far just to make sure that everything works. And, this is the goal that you're striving towards. You want to test the range of uses. You're not going to sit here and use it for yourself. Most probably you're going to share it with others. And how are you going to portray this information? You can do it with maps, charts, reports. I think that's the most common way to share information with geodatabase data. You're going to want to make sure that the features and the applications that you're using are in working order. They're not going to tie up your computer or not too complicated. You want to make sure that it's easy for people to use, and also that many people, if that's what your geodatabase is designed to do, many people can use this. So maps, I think, is probably the most common way to test it, and a reporting map is probably one of the most easiest ways to show people what exactly is in your database and the uses and the importance by showing reports, charts, tables. Geometric networks are a great way to analyze the relationship between point to point and flows between each other, the connectivity. And of course, publication and what's going to be your working product. What are you going to show a client or the end user? Now, revising the model. So you're going to use the data from testing to revise the model. Find problems, write these down, make the changes, implement them, and your testing is going to give you all the information you need to revise the model accordingly. That way, you can see any hiccups and what exactly the end goal is here. So when you're building a geodatabase, it's great to have a good plan. And I think a good database design really does provide a great base for a functional database. You don't want a whole bunch of random data together and no design on exactly how they go together, what they're doing, what's their relationship, and why is all this together. So I think using the implementation steps really does kind of help you flow your data in a way and to where the end user is going to understand, and yourself. See where you're going, what you need, what you don't need, that kind of thing. So to summarize, to build a great geodatabase, you're going to set up a design. You're going to add the data. You're going to modify the data. You're going to test the design with the data that you've got. And eventually you will have a final product. And all these steps kind of trickle down with each other to get you to a built database. So with this, go forth and build your fantastic database. Thank you.